Now look at this question. Evaluate the following without using table nor calculator. So the first one is sine 15. So whenever you are told not to use table nor calculator, there's an assumption. And what's the assumption? The assumption is that you should know the special angles. So how can you express any pair angle here to give us 15? So you can do 45 minus 30. So this sine 15 is something as what? Sine 45 degrees minus 30 degrees. So that's sine A minus B. Or sine A minus B, that's sine A cos B minus sine B cos A. So sine 15, which equals to 45 minus 30. So here it means A is 45, B is 30. That's sine 45 cos 30 minus sine 30 cos 45. What next? So we can return this back to 15. Sine 45 special angle is root 2 over 2. Cos 30 is root 3 over 2. Sine 30 is 1 over 2. Cos 45 is also root 2 over 2. So from here, sine 15 becomes root 2 over 2 is common, or in fact root 2 over 4 is common. Root 2 over 4 is common. And here I've left only root 3. And here I've left it nothing, because 2 times 2, 4 out. Root 2 out. So let's just put the 1 there. So we can say sine 15 equals root 2 multiplies by root 3 minus 1, everything over 4. That is the end of the first one. The second one, we have sine 225. So 225, this angle is in what quadrant? This is in the third quadrant. So because in several quadrants, angles are less than 180. This angle is more than 180 but less than 270. So how do we treat angle in several quadrants? First, we should know that sine is negative in third quadrant, because sine is only positive in first and second quadrants. So this angle is in third quadrant and sine is negative. So how do we express 225 as angle in first quadrant? So the formula is to remove 180 from that angle. Angle in first quadrant equals to angle in third quadrant minus 180 degree. So that's 225 minus 180 degree. And from there we should get 45. So it means sine 225 equals to negative sine 45. And that is negative sine 45 is root 2 over 2. And that is the answer. For question 3, sine 22.5. So how can we get 20.5? Definitely it is the half of what? 45 degrees. So we can write this as sine half of 45 degrees. So this is half angle. So question is, what the formula for sine half of A on that half angle? So the answer is square root of 1 minus cos A over 2. So it means sine half of what is A now? 45. Equals to square root of 1 minus cos, what is A? 45. Divided by 2. So half of 45 is 2.5 equals to the root of 1 minus cos 45 is root 2 over 2. Everything over 2. So if we share this 1 over 2 minus, that will be root 2 over 4. We can try to simplify further. The LCM here is 4. So that will be 2 minus root 2. So from here it means sine 22.5 equals to square root of 2 minus root 2. Root 4 is 2 over 2. That will be the final answer. The fourth one, 7.5. 7.5 is not a special angle. It's not half a special angle. It is actually half of 15. So we can say cos 7.5 is the same as cos half of 15 degrees. Yeah. So this becomes our A. So what's the formula for cos half A? Half arm for cos. That's square root of. What's the answer? Opposite to this. 1 plus cos A over 2. So it means cos half of 15 becomes square root of 1 plus cos 15 over 2. So let's just come this back to half of 15 is 7.5 equals to square root of 1 plus cos 15 degrees over 2. Now the problem is, what is cos 15? Similar to what we did here, cos 15 can be written as cos 45 minus 30. So using cos A minus B, cos A minus B is cos A cos B plus sin A sin B. So it means cos 45 degrees minus 30 degrees equals to cos 45 cos 30 plus sin 45 sin 30. Then from here, let's return it back. 40 minus 30 is 15. So it means cos 15 equals to, what's cos 45? Root 2 over 2. Cos 30, root 3 over 2. Sin 45, root 2 over 2. Sin 30, 1 over 2. So from here, cos 15 becomes, let's write together as root 6 over 4. Or let's say root 3. Root 2 times root 3 over 4 plus root 2 over 4. If I factorize, after factorizing, root 2 over 4, we will let it root 3 plus 1. That's cos 15. Then we'll come back here. So it means cos 7.5 degrees equals to square root of 1 plus, what's cos 15? Root 2 over 4 into root 3 plus 1 all over 2. Then we can write this as cos 7.5 degrees equals to square root of 4 plus root 2 into root 3 plus 1, everything over 8. This 4 multiplies this, then comes down. I think that's all. Let's try to expand. Cos 7.5 from here equals square root of, so I'll be having 2 times root 3, that's root 6, plus this and this root 2, plus what we have here, 4, all over 8. So that's the final answer. Now let's move to the fifth one, cos minus 750. For cos minus 750, the first thing you have to realize is that, or to know, is that cos minus A, same thing as cos A. So it means cos negative 750 is the same thing as cos 750. Now, whenever you see angle greater than 360, it means there is already what? A repetition. It's no more a cycle. What is a cycle? For cos, cycle is from 0 to 360. Let's see this 360, this 0, this 180, this 90, this 270. So for cosine graph, we have something like this. This is what we have. So this 360. So and this can repeat itself again over and over. So if we continue, so we are going to have something like this. This is another cycle. So this is a cycle for cosine. It's another cycle, and it goes on. So this is from here to here is 720 because this is 360, another 360, 720. So if we have 750, it means after 720 we are now having another 30 degrees. So where is 30 going to fall? This is 90, this 60, this 30. So something like this is 30. When you trace it back here, this is the value of cos that I want to get. But in order to avoid all this diagram and the likes, so this is what you do. You ask, how many 360 can you see in 750? So you can dash twice. So here, we can write 750 as 2 times 360, which is 720, plus what will remain at 30 degrees. So this will be as, just neglect this. Neglect the multiple of 360 and focus on the remainder. So what's the remainder? 30. So it implies that cos minus 750 you are looking for is actually cos 30. And what's cos 30? Special angle root 3/2. As simple as that. Just note, whenever the angle is greater than 360, you focus on the remainder after removing the highest multiple of 360. So if you know all the special angles, they can ask you compound angles, combination of two special angles, or you can take to quadrant when an angle is not acute, or you can have half angle, or a negative angle, or angle greater than 360. These are the possible angles you can be given. Just need to know how to manipulate for each. Look at this question. We have to show that cos 4 theta is what? 8 cos theta to the power of 4 minus 8 cos square theta plus 1. How do we go about this? This under compound angle. And what are we doing here? We are adding two angles. We can either use 2 theta plus 2 theta or 3 theta plus theta. But I think let's just use cos 2 theta plus 2 theta. Recall that cos A plus B equals to cos A cos B minus sin A sin B. And from here, this becomes cos theta cos 2 theta minus sin 2 theta sin 2 theta. Let's turn it back to 4 theta equals to, this is what? Cos square 2 theta minus sin square 2 theta. So we want our answer to have only cos. So what is sin theta? Sin square theta is 1 minus cos square theta. So this cos 4 theta, which is what? Cos square 2 theta minus, I'll replace this with 1 minus cos square 2 theta. Then here we have cos 4 theta equals to cos square 2 theta minus 1 plus cos square 2 theta. These two are like terms. So if we add, we have what? 1 plus 1, that's 2 cos square 2 theta, then minus 1. What else? Our answer has only cos theta, so we have to replace cos 2 theta. And what is cos 2 theta? Recall that cos 2a is what? Cos 2 cos square a minus 1. So from here, it means cos square theta will be same thing as cos 2 theta all squared, minus 1. Same thing. Our aim is to replace this cos theta with this identity. That's 2 cos square theta minus 1. Then recall it has another square there, minus 1. So this is cos 4 theta equals to 2. Now this is square of difference. So let's square this. That's 4 cos. If you square square, it becomes 4 to the power of 4. Square the first, minus twice their product. This times 1 is still this, then twice it is what? 4 cos square theta plus square the second 1 minus 1. So from here we'll be having cos 4 theta to be expand 8 cos theta to the power of 4 minus what? 8 cos square theta plus 2 then minus 1. So from here cos 4 theta becomes 8 cos theta to the power of 4 minus 8 cos square theta, 2 minus 1 plus 1. What happened? The left hand side equals to the right hand side, quad erat demonstrandum. And that's it. Look at this question. Show that this equals this. So we have to show the left hand side equals to the right hand side. So on the left hand side, you're having 1 minus cos alpha over 1 plus cos alpha. And here there's a little problem. Here you're having angle to be alpha, here you're having half alpha. So meaning we have to link this to half angle. So we should be able to express this cos alpha in terms of half angle. So We know that cos half of alpha, half alpha cos, equals to square root of 1 plus cos alpha over 2. If you recall from the identity. But what we need is actually cos alpha. So if you square both sides, it implies that cos square half alpha equals to 1 plus cos alpha over 2. And from here, if you make cos alpha the subject, we are going to get that cos alpha equals to 2 cos square half alpha minus 1. You make this one the subject. Multiply this one by 2, we move on from it. So what next? We can now come back to this relation. So we are having 1 minus, what is cos alpha? 2 cos square half alpha minus 1. Right? So this minus will affect everything. Divided by 1 plus cos alpha again, 2 cos square half alpha minus 1. So let's try to remove the bracket. So here we are having 1 minus 2 cos square half alpha plus 1 minus minus. Then here we'll be having 1 plus 2 cos square half alpha minus 1. So what do you have left here? So 1 plus 1 is 2. So we're having 2 minus 2 cos square half alpha over 1 minus 1 cancels. So we're having 2 cos square half alpha. What next? 2 is common here. So factorize 2. We left it 1 minus cos square half alpha over 2 cos square half alpha. 2 cancel 2. So what's 1 minus cos square A? 1 minus cos square x equals to sine square x. So everything here becomes what? Sine square. What's the angle? Half alpha. And what do you have at the denominator? We have what? Cos square half alpha. Sine over cos is tan, so this becomes what? Tan square half alpha, which equals to our right hand side. So from here, it implies that our left hand side equals to our right hand side. What are that? Demonstrate them. Something about this particular topic, trick 3, is to know all this identity by heart. So the compound angle, half angle, double angle, triple angle, sum to product, product to sum angle. And one of the ways to actually commit them to your memory efficiently is to practice questions using them. So solve lots of questions using those identities. Look at this Y question. It's an application question. And to be sincere, I'm seeing this for the first time. But something about mathematics is once you know the foundation, you can have the confidence that you can solve any question. So we are told that ABCD is a rectangle such that AB is greater than BC. Let us sketch it out. So let's label our triangle ABCD. Since AB is greater, so this should be AB. So label A, B, C, D. While labeling, must follow a particular direction. So, and O is the midpoint of DC. So O is the midpoint. Midpoint O, it means DO and CO or OC are equal. And we are told that OB is 0.1 meter. If OB is 0.1, where is it? OB. So this OD is B. So you have to join O and B together. So this OB 0.1 meter. And BOC is theta. BOC, this angle here is theta. Find an expression for the perimeter of the triangle in terms of theta. We want to get the perimeter of this triangle. What's the perimeter of the triangle? Addition of all the sides of the triangle will give us the perimeter. Sorry, there's a mistake in the question. The question didn't say the perimeter of the triangle. It's actually a rectangle. So let's change that. So we know the perimeter of this rectangle is addition of all the sides. So here we can easily get BC in terms of theta, since we know this hypotenuse, because this is 90 degrees. So this is opposite hypotenuse. So let's get BC. So opposite hypotenuse is sine. So we are having sine theta. What's the opposite? BC divided by the hypotenuse, 0.1. From here, if we cross multiply, it means BC equals to 0.1 sine theta. So if you know BC, we already know AD. We add this and this together. So we need to know AB. So how do we do that? We need to get OC. Why? Because this triangle, we can easily get the other side. So this is the adjacent hypotenuse. So that's cos. So if I do cos theta, that's the adjacent over the hypotenuse, 0.1. Similarly, if we cross multiply, we get OC to be 0.1 cos theta. So from there we can get DC. Since this O is midpoint, it means OD and OC be equal. OD and OC, they have to be equal. So it implies that OD is also equals to 0.1 cos theta. So what's the perimeter? So the perimeter is the addition of all the sides. First is AB, 2AB, perimeter is of his triangle was twice AB plus BC. That's AB plus DC, but they are equal, so 2AB. Then BC plus AD, 2BC. So from here, let's perimeter be P equals to 2. What is AB? That's OD plus OC. What is OD? AB itself, AB, from here to here, is same as DC. And what's DC? DC is OD plus OC. OD plus OC. So from there, it means our AB is OD. What's OD? 0.1 cos theta plus what is OC? 0.1 cos theta. So this is for AB. How about BC? BC is what? 0.1 sin theta. 0.1 sin theta. That's BC straight. From here, this is 2 into this, and this will give us 0.2 cos theta plus 0.1 sin theta. So this is expression for the perimeter in terms of what? Theta. We are done. Now we are told, find also the value of R and beta, for which the perimeter is what? R cos theta minus beta. Meaning we are told that if the perimeter is to be R cos theta minus beta, find the value of beta and R, or R and beta. So it means we have to express diameter in this form. Meaning everything inside here should be in terms of what? Cos. So if you look at them, they already look the same, but the thing is, some of our math is, don't worry, just continue, something will come out. Let's expand this. So here we have P equals to 2 times this will give us 0.4 cos theta plus 0.2 sin theta. What next? Let's expand this also. This is cos A minus B. So perimeter becomes R. Let's expand this one. That will be cos A minus B is what? Cos A cos B minus sin A minus sin plus sin A sin B. So this is cos theta cos beta plus sin theta sin beta. That's what that compound angle. This is our A, this is our B. Then this R is common. So if you expand, the R was there before. So if you expand, the R will affect it. So there will be R here. There will be R here. So, and according to the question, these two has to be the same. These two, they have to be the same. Because this is the perimeter we got, and this is the perimeter we are given indirectly. So what can we do? We can compare. This side we have cos theta, we have cos theta here. We have sin theta and sin theta. Since they are equal, so we can say it implies that R cos theta cos beta, this one equals to 0.4 cos theta. Same way, we can compare this side because this has sin theta and this also has sin theta. So you can also say R sin theta sin beta equals to 0.2 sin theta. And from here, cos theta cancels cos theta. So it means R cos beta is 0.4. Same thing here, sin theta cancels sin theta. So it means R sin beta is 0.2. So let's divide this by this. So I can come and divide this by this. So I'll write under this r cos beta, under this 0.4. Why? Because I know this will cancel this. Sine over cos is tan, so it means tan beta is 0.2 or 0.4 will give us 0.5. So directly we can get the value of beta, and beta here is what? Tan inverse of 0.5. Hence, we'll get the value of beta to be, and that will give us 26.57 degrees. So we've gotten better. What about value of r? You can come back to any of this relation. You can use this one. So since r cos beta is 0.4, so I will know the beta to be 26.57. So from here, r directly will be 0.4 divided by cos 26.57. Hence, the value of r would be 0.45. So we are done with the first part. Value of r and beta, for which the perimeter is this. Question answer, hence, find the greatest possible value of the perimeter. This is outside trigonometry. So recall, the perimeter P is given to be, from here, from the question, r cos theta minus beta. So the perimeter becomes, what's r? 0.45 cos theta minus, what is beta? 26.57. So this is the perimeter in terms of what? Theta. So it means the perimeter changed with this value, theta. So we are looking for the greatest possible value of the perimeter. The perimeter here is a function of this angle theta. So the greatest value, if you have to sketch this, this cosine graph, so we are going to have something similar to this, not actually this. So it's changing. So what's the greatest value in this case? This is it, the peak value. And what happens at the peak value? The gradient becomes 0. So it means f prime of theta must be 0 for p to be maximum or minimum. So this one actually means the gradient. What's gradient? Dy dx. In this case, the p, the theta, must be 0. So we need to differentiate this and set the answer to 0. So to be able to continue here, you have to know differentiation. This question is what? Application of differentiation. If you know calculus, you realize that by the time we differentiate this function with respect to theta, then the p, the theta, will be, if you differentiate cos, you get minus sine. That will be minus 0.45 sine theta minus 26.57. That is what we are going to get. And for us to get the maximum value, first we have to set this to be 0. So I said it here, this must be 0. So it means the whole of this will be 0. It means minus 0.45 sine theta minus 26.57 must be 0. So sine what will give us 0? Sine 0 will give us 0 for sine graph. Sine 0 will give us 0. Sine 180 will give us 0. Sine 360 will give us 0. If you divide both sides by 0.45 or minus 0.45, this one cancels, so just have sine theta minus 26.57 equals to 0. So since sine 0 will give us 0, so we'll come here and say the whole of this has to be 0. Since sine 0 is 0, it means theta minus 26.57 is also 0. From here it means theta equals to 26.57 degree. But this value we don't know if it's going to give us the minimum or maximum value. Because sine has maximum value before minimum. So the smaller value give us maximum, the bigger value of theta will give us what? Minimum. So since this is the smallest value theta can have, between 0 and 360, so it means this will give us the maximum value of the function. So for us to get maximum value, now come back here. So you're looking for the maximum perimeter. For the perimeter to maximum, it means this theta here must be 26.57. So by the time I put it here, 20.7 minus 20.7 gets 1. Sorry, gets 0. And because 0 is 1, so it means the perimeter will be 0.45. Perimeter is 0.45 units. I'm not given the units, so just write units here. So this is what? The maximum perimeter. Maximum perimeter. Or better still, since you don't know calculus, after getting here, so just forget everything here. I'll assume you don't know calculus. Note, if you press cosine of any number, the maximum you can get is 1. If you press cos 10, cos 20, cos 100, cos 1 million, cos 750, the highest answer you can get is to get 1. Yes. So for P to be maximum, cos x must be maximum. And the maximum you can have is for it to be 1. So just multiply 0.45 by 1 straight, you get the answer. It works for this particular question, but it might not work for other question. So I need to follow this step for other question, but for this particular one, just know for P to maximum, cos function name was maximum, and the value is 1. So 1 times 0.45 is what? 0.45. So one side is what? 0.45 units. Oh, we are giving unit here, meter. So that will be 0.45 meter as the what? Maximum perimeter of the rectangle. Look at another y question. If tan half of a is t, derive an expression for cos a and sin a in terms of t. Hence, or otherwise, prove that if sec a minus tan a is x, then tan half of a is 1 minus x or 1 plus x. There are many ways this question can be approached. First, look, this is half angle, but these are not half angle. So if tan half of a equals to t, remember that tan is 12. So it means you can write it as t over 1. And that's opposite over adjacent. That's 12. So if you have a right angle triangle, where let's suppose this is our angle, this half a. Our angle, half a. So the opposite is what? T. And the adjacent is 1. What will be the hypotenuse? We can get the value, let's call it x. Oh, there's already x in the question, let's call it y. So from here, y squared equals to 1 squared plus t squared. So y equals to 1 plus t squared. So we can see y equals to square root of 1 plus t squared. So we can replace this with what? 1 square root of 1 plus t squared. So we've gotten the hypotenuse. So from this triangle, we can actually get sine half of a. And we can also get cos half of a. What is sine? Opposite over hypotenuse. Opposite hypotenuse, that's t over root 1 plus t squared. What is cos? Adjacent over hypotenuse, that's 1 over root 1 plus t squared. So that's sine half of a and cos half of a in terms of t. We are looking for cos a and sine a in terms of t, not half. So recall, sine half of a equals to square root of 1 minus cos a over 2. From here we can get cos a. So what will be cos a? That will be 2 sine square half of a. That will be 1 minus it. If you square it, you bring 2 here, then that will be 1 minus. So from here, if you make cos a the subject from here, change the formula, cos a becomes 1 minus 2 sine square half of a. Then from here we can say cos a equals to 1 minus 2. What is sine half of a? So that's 2. Sine half of a is what? T divided by square root of 1 plus t squared. we have a square here also, all squared. So it means cos A equals to 1 minus 2t squared over 1 plus t squared. So we can write this as cos A equals to 1 plus t squared minus 2t squared over 1 plus t squared. From here it means cos A equals to 1 minus t squared over 1 plus t squared. So we derive the expression for cos A in terms of t. If you know cos A, we know sin A already. There are many ways you can do this. So this adjacent, this hypotenuse. So we need to get the opposite. So what's opposite? Opposite is square root of hypotenuse squared. That's 1 plus t squared all squared. Minus what? Opposite squared. That will be, so adjacent squared, that will be 1 minus t squared all squared. This is from Pythagoras theorem. We know that sin square A equals to 1 minus cos square A. So to get sin A, we square root both sides. So it means sin A equals to square root of 1 minus cos square A. We square this one. That will be 1 minus t squared over 1 plus t squared all squared. Then we can simplify this further so that we can get sin A in terms of t. So if you split this square from numerator and denominator and look for the LCM, you get this. And here we don't need to expand because that's different of 2 squared. So we add, then we subtract, then at the end we have. So if we add this with this, t squared minus square cancel, 1 plus 1 is 2. Then we subtract, I'll be having t squared, 1 minus 1 will cancel. T squared minus t squared is what? 2t squared. Divided by 1 plus t squared all squared. From here, sin A equals to square root of 4t squared over 1 plus t squared all squared. So if you look for the square root of 4 is 2. From here, we can just say sin A equals to root 4 is 2. Root t squared is t. Over, then this square root takes the square away. That's just 1 plus t squared. As simple as that. Like I said, there are many ways of doing this, but this is the way that came to my mind. So this cos A, sin A in terms of t. The next part hence, if sec A minus tan A equals to x, then we have to prove that tan half of A equals to 1 minus x over 1 plus x. So this is what we are told to show if this condition holds. So what are we going to do about this? So how are you going to look into this? Note, we are already told from the beginning that tan half of A is t. Tan half of A is this. So in short, we are told to show that t equals this. Because tan half is so what? It's also t. So how do we get t? We come back here. What is sec 1 over cos? What is tan? Sine over cos. So let's impute the value of, okay, let's go back to the expression. This sec A is written as 1 over cos A minus 1 tan A sine A over cos A, and is equals to x. Our aim is to get x in terms of t. They make t the subject. So this is written as 1 minus sine A over what? Cos A. So that's 1 minus, what sine A? This is it here. 2t divided by 1 plus t squared. Then divided by cos A. What is cos A? That's 1 minus t squared over 1 plus t squared, and the answer equals to x. So this is what? 1 plus t squared minus 2t over 1 plus t squared times 1 plus t squared over 1 minus t squared equals to x. This cancels this. So this is like a quadratic equation. That's t squared minus 2t plus 1 over this common it 1 minus t squared. I can also write as 1 squared minus t squared equals to what? X. If we factorize this will give us t minus 1 all squared. So Because if you expand this, you should get this back. Then over difference of two squares, we add and we subtract 1 minus t, 1 plus t equals to x. So t minus 1 can also be written as 1 minus t, 1 minus t. This is now 1 minus t, 1 minus t. It is allowed. So what next? This cancels this. This over 1. Let's cross multiply. X times this one, that will be x plus xt equals to 1 minus t. Our aim is to get the value of t, right? So from here it means xt plus t equals to 1 minus x. And from here x is common, or t is common. T into what? X plus 1 equals to 1 minus x. So we can divide both by x plus 1 over x plus 1 over x plus 1. So t equals to cancel 1 minus x over x plus 1 is equal to what? 1 plus x. So recall that you can finish yourself. 6 tan half of a is t. And t equals to 1 minus x, 1 plus x. So it means tan half of a is what? 1 minus x, 1 plus x. Or let me just write it. So from there, it means t is what? Tan half of a. Since t equals to t, it implies that what? Tan half of a equals to 1 minus x over 1 plus x. Quod erat demonstrandum. That's the end. I think I can stop here and go and rest. The end of week 3. Everything I leave it for you. I have done what I think I should have done. See you in my next class.